Chapter 3 is numeration systems and whole number operations. So in section 3.1, we're going to start by looking at numeration systems. After the end of this section, you should be able to understand and explain numbers, their origin, and their representation in numerals and models. You're going to know different numeration systems, including the Hindu-Arabic system. You're going to be able to know about place value and counting in base 10 and other bases. This is going to be really important. And you're going to see some issues in learning with different numeration systems. So let's get started. So numerals are just written symbols that represent cardinal numbers. So what you see on your screen here are a bunch of numerals that were used at different stages in history. So this top one is the Babylonian numeration system. Then we've got Egyptian and Mayan. We're going to look at all three of those. The Greek numeration system you might be familiar with a little bit. The Roman numeration system you've probably seen in grade school yourselves. If you look at the last three, I guess, the Hindu-Arabic, those look really close to the numbers that we are used to, the Hindu and Arabic. And when we get to the Hindu-Arabic, that is the numeration system that we use today. Okay, so what do I mean when I say numeration system? It's just a collection of properties and symbols that we've agreed upon to represent numbers systematically so that everyone knows what we're talking about when we write down these digits. In the system that we are used to, the Hindu-Arabic system, all numerals are constructed from the 10 digits. So we have 0, 1, 2, 3, all the way up through 9. And our place value is based on powers of 10. So here's an example. I have the number 5,678, and if you look at that number, we know that the 5 is in the thousands place, which represents 10 cubed, and the 6 is in the hundreds place, which represents 10 squared, and so on. This is something you've probably seen before, but this place value is really important, and this is going to be the foundation for your students to really understand what we're talking about when we're dealing with numbers. So I can write any number in its expanded form by showing what those place values are. Okay, so 6,789 is telling me that I have 6,000, so 6 times 10 cubed, plus 700, so 7 times 10 squared, plus 8 tens, or 8 times 10 to the first, and finally 9 ones, or 9 times 1. Realize that 1 is the same as 10 to the 0. Just to make sure we're all on the same page here, this should be a ... I'm not sure why it's a capital K. But when I take any number a to the power n, what that's telling you to do is take a and multiply it by itself n times, right? So 10 cubed, for example, is 10 times 10 times 10, which is 1,000. Okay, so we want to look at different ways to help kids visualize numbers. And so the first thing we're going to look at here is base 10 blocks. So I'm going to think of a unit as just this little block, and we'll get these out in class. 10 units is going to be, if I have 10 units, I'm going to glue them together into this stick figure looking, and we're going to call that a long. So that's 10 units. And now if I go to 10 squared, I'm going to have 10 longs glued together, and we're going to call that a flat. So this is my 100 unit, or my 10 squared. And finally, if I take 10 flats and glue those together, that's going to build a block, and that's going to have 1,000 units in it. So that's my 10 cubed. All right, so I want to use those to represent numbers. Let's look at an example. I want to know what's the fewest number of pieces I can receive in fair exchange for 11 flats, 17 longs, and 16 units. So I'm going to start by writing out what I have. And remember, if you look back at the picture here, anytime I get 10 of a smaller building block, so say 10 units, I can glue those together to build a single long. And so that's what I want to use to exchange my pieces. So I'm going to start by looking at my units, and I had 16 units, so I'm going to take 10 of those and turn them into a long. So there's my 10 units, and I'm left with 6 units, right? So now I have 11 flats, 18 longs, and 6 units. I can't do anything more with the units, so I'm going to move up to the longs. I have 18 longs. Anytime I have 10, I can glue those together and move them up to the flats. So I'm going to break that 18 into the 10 longs to get 1 flat, and then 8 remaining longs. Okay, so that's what we're doing off to the side. And so I'm going to trade 10 of those here to get a flat, so I'm increasing my flats by 1. And I've got 12 flats, 8 longs, and 6 units after that trade. All right, now I can't do anything more with the units or the longs, so we look at the flats. There are 12 flats. Again, anytime I get 10 of something, I'm going to glue it together and move up a figure. So here I have 12 flats. I can take 10 of those and glue them together to make a block. And so I'm going to have 1 block and 2 flats remaining. And so in the end, I have 1 block, 2 flats, 8 longs, and 6 units for a total of 17 pieces. So the fewest number of pieces I can use to represent the same amount that I started with is 17 pieces. Okay, this is analogous to writing. So what I started with was 11 flats, 17 longs, and 16 ones, right? So that's what that first number represents. And I could rewrite that as 1 times 10 cubed, so that's my 1 block, plus 2 times 10 squared. There's my 2 flats. 8 times 10 is my 8 longs, and then 6 is my 6 units. Okay, so those are the blocks.